Okay, in this assignment, we're simplifying exponential expressions. Make sure that when at the end of your simplifying that there are no parentheses left, no powers raised to another power. Each base occurs only once. That means you have like a number and then each variable one time. And then no negative exponents and no zero exponents. So that's something that we need to add right here. It's no zero exponents. All right, so now when showing each step, we have to use these rules. Product of powers, you know that it tells you that if you have a to the n times a to the m, and you are multiplying them, then you add your exponents. So this is adding your exponents. Quotient of powers says that when you have an over am, then you subtract your exponents. You subtract your exponents. And then zero exponent says that anything to the 0 power is 1. Negative exponent says that if I have a to the negative n, then you have to bring it to the denominator and make that exponent positive. Do not change the sign of the a. The a, this number down here is dependent on what this exponent is and what a is, obviously. All right, power of a power, that's if you have you have an existing power and then you have to raise it to another one. That is when you multiply your exponents. So this is multiply, and that's power of a power. And then power of a product. So that means if I'm multiplying two things together or multiple things together, but then I take it to a power of, let's say, m, that means that everything inside gets that m exponent. So everything inside gets that power. Same thing with power of a quotient, but quotient is division. So you're looking at a division problem inside of a parentheses, and then you raise it to an exponent. Then again, everything, the top in the parentheses gets an exponent of m, and the bottom, the denominator, gets an exponent of m. All right, so these are our rules, okay? And what you're going to do is when you are simplifying these rules, simplifying the problem, each step has a particular rule that allows you to take that step. So looking at this first one here, I notice that we have a power of a product because 2 and x to the 8th and y to the negative 4 is all being multiplied together in the inside, so that's called a product. And this product has a power on it, so that's why it's power of a product. Now again, power of a product says that everything gets an exponent. Everything gets an exponent. So that means that the 2 gets an exponent of 2, and that's the x to the 8th gets an exponent of 2. And then y to the negative 4 gets an exponent of 2. So rule of thumb, if it already has an exponent here, put parentheses around it and then take it to another exponent, because that'll lead you to your power of a powers here. And power of a power says that you multiply your exponents. So because of the power of a power rule, I'm able to take this expression. You can do 2 squared is 4, but it says that I can multiply these exponents here because if this is a power raised to another power. So that will become x to the 16th, and this will become y to the negative 8. Now, in here it says that I cannot have any negative exponents. So there goes my third step, my negative exponent rule. What do I have to do? I have to take this y to the negative 8 and I have to bring it down underneath into the denominator to make it positive 8. So now my simplified answer is going to be 4x to the 16th, all divided by, and then this goes on the bottom, y to the positive 8. And that is my answer. So let's go ahead and look at the rest of the assignment. All right, so again, you already know this. This is a product, so we have a power of a product. So we got a power of a product, and a power of a product says that everything gets an exponent. So the -3, and I'm going to go ahead and put that -3 in parentheses as well, so that you know that you have to multiply the negative as well. So we got -3 to the third power, and then we have x to the fourth to the third power, and then we have y to the fifth to the third power. All right, now we have our powers of a powers. So there's the power of a power rule. And power of a power rule says that I multiply them. So let's go ahead and simplify this. What is -3 times -3 times -3? Because that means multiplying -3 3 times. So -3 times -3 is +9, and 9 times -3 is -27. Okay, now I'm going to multiply 4 times 3, and that's going to give me x to the 12, and then y to the 5 times 3, and that's y to the 15. And this is my simplified answer, because I have no negative exponents, and I have no zero exponents, no parentheses, and no powers of powers left. And each base, an x and a y, there's no multiple x's, no multiple y's, so this is my ending simplified answer. Okay, let's look what we have here. Here I have a product being multiplied to another product. So this is a product of powers. A product of powers, when it's just straight multiplication like this, a product of powers. Now I know this is not a simplified answer because I have two x's here, and I have multiple y's, and then I have this coefficient that I can multiply, these coefficients that I can multiply together. So the first thing I'm going to do is multiply -7 times -2, my coefficients, which is 14. Then power of a product of a power says that I'm going to take my x here, x to the 1, multiply it x to the 5, so I have 1x being multiplied to 5x's, which means that I'm multiplying 6 altogether, so I add my exponents. Now the same thing with the y's, y to the 4 times y to the 6th is y to the 10th, because I have 4 y's, y times y times y times y, and then I'm multiplying 6 y's over here, y times y times y times y times y times y, and if you multiply all this together, you have 10 y's in all that you're multiplying. And this right here is my simplified version. So this is equivalent to this answer here. It's just simplified. It's shorter. So this question here was simplified in 2 steps, whereas this is simplified in 1 step. So let's go ahead and look at the next one. This will be simplified in 1 step, because this is a product of powers. All you're doing is multiplying. So product of powers rule. Product of power rule says I add my exponents. But first I'm going to go ahead and multiply this -6 and 3, which gives me -18. Then I'm going to look at my x's. I have x squared, and then I have an x to the 1. And I'm going to add my exponents. So that's 2 plus 1 is 3. So x to the 3rd power. And I'm going to go do my y's now. Y to the 5th times y to the -3. So I'm going to add these. What is 5 plus a -3? So y to the 5 plus a -3. Now 5 plus a -3 is the same thing as 5 minus 3. So this is going to be y squared. And we did do the x and the 2 plus 1. So if you want to write that down here, you can do that. Okay. Same thing with this one up here. You can do the x to the 1 plus 5 just to show what you did, and the y to the 4 plus 6. Okay, so now let's look at this one right here. Now this doesn't have parentheses around it, doesn't have a power, so this is just a division problem. So this is called a quotient of powers. That's going to be the first step because I see a division problem. Quotient of powers rule. Now, quotient of power rule says that because I'm dividing, I'm going to subtract my exponents. But I have coefficients in the front, so I'm going to do this first. So negative 35 divided by 5, that is negative 7. Okay, now I'm going to take my x's and I'm going to subtract my exponents. So I'm going to do x and then 2 minus 6. So that's going to be x to the negative 4. And then I'm going to do my y's now. Be careful of this because the negative 8, you're still going to do 4 minus and then a negative 8. And these two negatives will make a positive. So this is actually 4 plus 8, which gives me y to the 12th power. Now this is not simplified yet because of this negative exponent, so my next rule is going to be to apply the negative exponent rule. The negative exponent rule. And the negative exponent rule says that I'm going to take this and bring it to the denominator. So negative 7 y to the 12th stays on top and x to the 4 because we have to now change this negative to a positive when we move it. X to the 4 is on the bottom. This is my simplified version. And I did that problem in 2 steps, you applying 2 rules. Alright, turn to the back. Alright, again we have a quotient. We have a quotient of powers, a quotient of powers rule because you have a division problem. And again, the first thing we're going to do is divide the numbers in the front. So that's coefficients. So 100 divided by 20 is 5. And then we're going to take each base. So we got these bases of x. And what we're going to do is we're going to take it and then we're going to do negative 2 and then we're going to subtract because that's what quotient of powers is, subtract your exponents. Negative 2 minus a negative 4. So this will turn into a plus. So negative 2 plus 4 is just a positive 2. So this is x squared. Now we're going to do the same thing with the y's. Y and then to the 6 minus 3. And that'll just give you y to the 3rd power. Okay, now this one right here. This is a quotient because it's a division, but I have parentheses here and I have a power. So that's going to be called a power of a quotient. And a power of a quotient rule says that this top gets an exponent of negative 3 and the bottom, the denominator, gets an exponent of negative 3. So let's go ahead and show that here. So we're going to put the top in parentheses. And we're just going to break it up and put the top to the exponent of negative 3. And then we're going to do the same thing, put the bottom in parentheses, and we're going to put the bottom to the exponent of negative 3. Now, first step, power of a quotient. Now when we broke it up, I created a power of a product, and that goes to the next step. Power of a product, and power of a product says that everything on the inside of this parentheses also gets a power of negative 3. So let's go ahead and represent that, show that here. So we're going to do 4 to the negative 3. Now put x squared in parentheses since it already has an exponent, raise that to another negative 3. So now I created a power of a power there. Go ahead and do your d cubed, and that means cube, to the negative 3. D to the 3rd power to the negative 3 power. Then give me my division sign and do the same thing with the bottom. Y negative to the negative 7 to the negative 3. And then G to the 4 to the negative 3. So I have a whole bunch of power of a powers here, which leads me to my next step. power of a power. When I see two exponents like this, what do you do with the exponents? You multiply them. So let's go ahead and rewrite this and reflect that all we're doing is just multiplying our exponents here. So we're going to do x to the negative 6, d to the negative 9, y to the positive 21, and g to the negative 12. Now, it's not simplified yet because I have a whole bunch of negative exponents. A whole bunch of them. Negative exponent says that I changed their position. This one's going to move to the bottom. This one's going to move to the bottom. This one's going to move to the bottom. This one's going to move to the top. So if it's in the top, it moves to the bottom. If it's in the bottom, it moves to the top. And you change its sign. So we're going to go ahead and move this to the bottom. Now instead of putting 4 cubed, for time's sake, 4 cubed is just 4 times 4 times 4. That's 4 to the third power. Sorry. So 4 times 4 is 16, times 4 is 64, so we're going to have a 64 down here at the bottom. It's going to put a 1 at the top. Now the y to the 21 stays at the bottom. This x to the negative 6 moves to the bottom, so x to the 6th power is going to be on the bottom. The d to the 9 moves to the bottom. And the g to the negative 12 moves to the top. So g to the positive 12. Now, normally you would put all this in alphabetical order, but for this assignment, it's fine. That means that this would be 64, d to the 9, x to the 6, and then y to the 21 power. All right, so there you go. This happened that we simplified this in 1, 2, 3, 4 steps to get that. This problem is equivalent to this answer here. So they're the same thing. All right, let's do this. Again, we have a power of a quotient. Power of a quotient. So we're going to write that down first because that's the first step I'm going to do. Power of a quotient rule. Again, that means that the top of the numerator, that's what you call it, the numerator gets a power of a negative 5, and the denominator gets a power of negative 5. Now practice on putting parentheses around that product and that product, okay? When I did that, I created a power of a product. So I'm going to do power of a product rule, which means that everything inside of this parentheses gets a power of negative 5. So we're distributing that power per se. So let's go ahead and do 5 to the negative 5, x to the negative 8 to the negative 5. Then on the bottom, I'm going to do 2 to the negative 5, and then this y to the 4 to the negative 5. Now when we did that, we created power of a powers. Leave the negative exponent at the end. Okay, so we're going to do power of a powers first. So rewrite the 5 to the negative 5. We're going to get to that. But this power of a power rule says that all I have to do is multiply these exponents to the exponent. So negative 8 times negative 5 is 40. Then this is 2 to the negative 5, and then this will give you y to the negative 20. Okay, now I can go ahead and take care of my negative exponents with the negative exponent rule. That means that this moves to the bottom as 5 to the 5th power, and 5 to the 5th power is, let me go ahead and calculate that real quick. $3,125, and the 2 to the 5th power is equal to 32. So the 3,125 goes at the bottom because that's 5 to the 5. 5 to the 5th power, 325. This 2 to the 5th goes to the top, so that's 32 on top. Okay, now this x40 doesn't move because it's positive and stays there. But the y to the negative 20 moves to the top as y to the positive 20. And there you go. We completed this problem. We simplified this expression in 1, 2, 3, 4 steps to get this equivalent answer. All right, last one. We have not used that zero exponent yet, so this is going to be the problem with that zero exponent. But see, you don't see it. You don't see it yet. So all I see is that I am multiplying a lot of things together, so that's called a product of powers. Product of powers. Product of powers. So coefficients first. 4 times 1 is 4. Okay, now look at our a's. We got a squared times a to the 1, and a squared times a to the 1 is a to the 3rd power. Now my b's, we got b to the 4 times b squared, which is b to the 6th, because again we add, so b to the 6th power. We add those exponents. Okay, now let's do our c's. We're going to do c to the negative 2 times c to the positive 2, and the negative 2 and positive 2 will cancel out because negative 2 plus 2 is 0. Okay, and that will be c to the 0. So negative 2 plus 2 will give me 0. And again, if we do this by the negative exponent rule, this will go to the bottom. And remember when I said if you have the same thing on the top divided by the same thing on the bottom, it cancels out and it equals 1. So that's really what's happening here, is you have c squared here, but because this is a negative exponent, this c squared is going to go on the bottom, and since I have the same thing on the top and the bottom, this divided by this is equal to 1. So that's why we can say that because of the zero exponent rule, right here, anything to the 0 power is equal to 1. So we can replace this with 1, and 1 times anything is itself. So my simplified answer is 4a cubed times b to the 6th. 4a to the 3rd power times b to the 6th power. And I'm done. This here this expression is equivalent to this answer right here, and we did it in 2 steps. All right, make sure that you complete this assignment and turn it in on Monday, or go ahead and submit it in Schoology.